and 1,270 in Ahwatukee. Now I'm not authorized to evacuate Ahwatukee, but this temperature seems pretty high.
Cade Creek is really
Yeah, Cade Creek, Fountain Hills, they don't look good either. And frankly, Wickenburg is a total loss.
Continuing coverage now, that massive snowstorm hitting the Northeast right now. If you're headed to Tampa International Airport, before you walk out the door, make sure you check your flight. That massive storm is blamed for canceling 20 flights, you see them right here, and delaying another 180 from Tampa since yesterday.
Hello again. Just to recap on what our project is about, there are two key objectives that we hope to achieve as part of this project.
The first is to develop an interface of existing weather radars on XRAD, obtained from open source information and shown on the Google Map interface. We also developed the engine running in the background to calculate potential interference when planning to situate new radars.
The second part is to make use of weather and flight delay information available from open sources, and then use analytics tools to predict possible flight delays based on weather forecast. As for the technologies used to develop our software, there are no major changes from our previous update. Our key source of data comes from web services provided by the National Weather Service and the Bureau of Transportation Statistics. We then developed models for both radar interference engine, and this week we successfully developed the linear regression model for the analytics and prediction of flight delays. We made use of pieces of code from NPM to convert from CSV file format to JSON, and to help us crawl weather data from the web services. Our software is based on JavaScript, and we make use of jQuery to handle and manipulate information and events. And of course, in the presentation layer, we make use of CSS, HTML, and Google Maps for visualization.
The server is run on Node and directs the client to the HTML page when the correct address is input. It also takes inputs with the express get function to add or remove entries from the database. The bulk of the functions responsible for writing into the database is found in the API file. These functions are called by the server when the correct express get conditions are satisfied. Finally, the HTML file uses jQuery to read from the database files, calculate interference levels from the entries, and plot the markers on the map.
Moving on to the code walkthrough for the flight delay analytics module, we have added a new JavaScript file to take in both the flight delay and weather information, matching them to the same date. We then use this information to create a series of charts and to find the strength of correlation between the different weather elements with the flight delay that's occurring in a particular state. Lastly, using two of the weather elements with the strongest correlation, we developed the linear regression model to help us predict possible flight delays based on forecasted weather conditions.
This week, we added some error handling, as well as additional interface features to the interference module. Clicking the Place Sensor button when no latitude or longitude is selected, or removing a sensor that does not exist, would result in an error. Users can now delete individual systems by clicking on a delete button found within user-created info window. Also, the HTML div sizes now scale dynamically with screen size, making the application usable on a handphone or tablet. We have tested the application, letting multiple users log in and use the application at the same time, and there do not seem to be any issues.
What you see here is the flight delay analytics part of the project, consisting of three sections. The first section displays the magnitude of flight delays attributed to weather conditions as indicated by the red bubbles, and also the temperature across all states. If we look at the time lapse over the period of 6 years, you'll notice that most of the delays occur in the Michigan area, especially during the winter season. In the second section, we try to analyze the data further based solely on Michigan data during the winter months. The four charts here show the strength of correlation between the weather elements and flight delay. As we can see from the R2 values, the amount of snowfall and wind speed, which are the second and the fourth chart, seems to show the strongest correlation. For simplicity, we then make use of the amount of snowfall and wind speed as our variables for prediction. So let us assume we are expecting a wind speed of 20 km per hour and a snow depth of 10 cm. And using the multiple linear regression formula, the predicted delay is as shown below. Notice that as small data is fed into the system during the time lapse, the model makes use of machine learning to try to give a more accurate prediction using a larger data set. And finally, we have been able to mitigate and close all the risk areas that we've identified earlier. Particularly on the last point, we managed to add wind speed to the list of weather elements and found that wind speed had quite a strong correlation with flight delays. This may be true since pilots tend to avoid regions with storms building up. We also found that rather than using data from all the states that we have, it is important to focus our analysis on one of the states, as different conditions in other states may weaken any correlation that we have observed earlier on.
We hope these applications will be interesting and useful for weather and airline industries and improve their productivity and prediction capabilities.
Thank you for your attention. If you have any queries, our email address can be found below.
You know, again, I'm not your dad, but I would get out while you still can. I think steel boils at about this temperature.